Hello dear students, welcome back to study physics, guys. Again, we finished chapter 1 all, and even we finished chapter 2. Now we have new chapter, chapter 3, section 1. This chapter in general, it's about fluid and the property of the fluid and solving some calculation. So first section that you have in here is section 1. In general, it's about fluids and certain fluids and buoyant force. This lesson, inshallah, we will study what's the meaning of fluid and difference between liquid and gas. Some properties we can separate between liquid and gas. So how we determine the magnitude of the buoyant force existing in the flowing object, or the object goes and the water is submerged, and explain how or when the objects will float or where the objects will sink. Inshallah, we will study all this. Okay, guys, first, let me tell you what's the meaning of fluids. Fluids, a non-solid state of matter in which atoms or molecules are free to move past each other as in gas or liquid. Guys, in general, know that just fluid, it's a mixing between liquid plus gas. So together, it's called fluid. Non-solid state of matter. So it's fluid, non-solid, except solid. Two things, it's mixed liquid plus gas, it's called fluid. A non-solid state of matter which atoms are moving past each other, are free. So understand fluid is passing between liquid and gas in general. To this and the liquid and the gas, they are mixed, it's called fluid. The property of the we have a question here. Look, before to explain the question, look, you have this note. Matter normally classified as being in one of three states of matter: solid state, liquid, or gas. Even we studied in chapter 2. It's not new. We have an important question. What are the common properties between liquid and gas? The ability to flow and alter their shape. Let me tell you about this picture. Look, Bab. The pictures, look. You have picture A and picture B. Look at this figure. Figure A is liquid, but figure B is gas. Look, we have two same property between liquid and gas. Two same property. First property, liquid. Look, this is liquid. The first liquid is inside this container. After is flowing to come to another container in here. Look. So the first property, we can say that liquid can flow from one container to another container. First it was in this class or this container, then they are flowing to another class. So flowing, first property of the liquid. Even same property you have in gas. Look, this is gas in the same glass like as liquid. They can flow to another container. So that's why the common property between the same property between liquid and gas, both they have ability to flow. So flowing for gas and liquid. The second property of the liquid and gas, both that they have same property, alter their shape. Alter, it means they can change their shape. Unlike liquid, we said the liquid take the shape of the container. For example, look at this picture. At first, the liquid, it was in this container, it take the shape of this container, but after when it's flowing, it's come inside this container, then it take the shape of this container. Look, so liquid take the shape of the container. Gas, same thing. Look, same thing. First, it was in this container, then they are flowing. It took the shape of this container. So liquid and gas, both they can't change their shape. It take the shape of the container. That's why in here we have this important question. The first property between liquid and gas, ability to flow. Now we mentioned both they have ability to flow, gas and liquid. The second step, alter their shape or changing their shape. As you mentioned, take the shape of the container. Another property you have, liquid have a definite volume. Of course, the volume of the liquids is different, but gas, no. Gas, they change their volume. Look, I wrote change volume. So liquid, the property different volume, but gas will change. So the common property between liquid and gas, both of them, they can change their shape and they can flow from one container to another container. We have another important question. Why solid object? Solid object are not considered to be fluid. Why we cannot say solid? It's like a fluid. Because solid, as we know that solid, it's solid, like the property. They don't have ability like a liquid and gas. They cannot flow. Look, they cannot flow and therefore have definite shape. But no, liquid and gas, we said the shape will be changed and even they can flow. But solid, no, they cannot flow and they have a definite shape, not changing their shape like a liquid and gas. That's why we cannot say solid, it's like a fluid or it's like a liquid or gas, because of this two reasons. They don't have ability to flow and have a definite shape. Okay, guys, we have another topic. It's called density in general. This is the rule of density. Density, this is a symbol, rho equal mass over volume. This is the rule of density. So the definition, you can say the relation between mass and volume. Look, mass per unit volume of a substance, and this is the symbol of its rho. We have a question. What does mass density depends on? Guys, in most of the lesson of physics, we can get the factor or the parameter is depends on what you can get by the rule. Actually, look, we have the rule. So density is equal to mass over volume. So the factor, of course, that can affect density is mass and volume. That's why the answer object mass and object volume, because by in the rule we have these two things. Just we have density. Just we have mass and volume. That's why only you have these two factors, mass and volume. And even in chapter 1 we mentioned that the unit of the density is kilogram per meter cube. Guys, this is same definition. Mass density is mass per unit volume, and the factor we said depend on the mass and volume. Okay. Guys, you have this table. It's just for information, but the density of waters. Where is the density of the water? We have to memorize it actually. Fresh water, that one. 1 times 10 power 3. This is a density for all of the substance. 1000. The other just for information or just memorized. For example, density of the air is 1.29 and density of the iron, because we have some examples. You have to know the density. Even your teacher may be gonna give you the exam, but it's better to memorize it. Some of them not. The air and the waters are enough. This density memorized. Guys, we have an important topic. It's called buoyant force of an object. What's the meaning of buoyant force? It's a force that is on the object. That's why it's called buoyant force. Look, let me explain the meaning of buoyant force. Imagine we have in here is water, and this is the surface of the water. Surface of the water. On the surface of the water, we have an object, any object. this object is on the surface of the water. Guys, this object on the water's two force can affect this object. Two force. The first force, all times the direction is from the downward, it's called Fg, force of the gravity. Fg, the force that can affect the objects from the downward, the direction. But our topic is about buoyant force. The buoyant force can affect the object, but the directions is all time from the upward. This is called buoyant force. Let me tell you, we know that Fg is gravitational force. The Earth can attract the object from itself by the gravity force. But what's the meaning of buoyant force? Guys, actually buoyant force in here is the force of the waters that can push the objects to stay on the surface. Is the force of the water that can push the object to stay on the surface of the water, to do not sink. So now we understand buoyant force is the force of the waters. Look, another picture. We have, this is the water. This is the water. We have this object on the water, and we said Fb all time from the up. The direction of Fb, this is the force of the water that can affect this object to stay on the surface. To stay on the surface. So because of this buoyant force that the waters can stay on the surface, because buoyant force, the waters have a force, buoyant force is from the upward that can push this object to stay on the surface. So without the buoyant force, the water sink. Then later we will study it. We have some situation, some condition, the water sinks, goes under the water. We have some condition, but in general, Fb is the force of the water that can push the object to stay on the surface, and the direction is all times from the up. This is the buoyant force actually in general. So we have definition. Look, buoyant force, it means Fb, a force that acts upward on an object. As we mentioned that, for example, we have this object, directions from the up, Fb. Submerged in a liquid or floating the liquid surface. When that we have buoyant force in two situations. When the object can stay on the surface, you have buoyant force, or the object that goes under the waters. This is the surface. The object is on the surface, or the object is under the water, or not water, any type of the liquids. In this situation, we have a buoyant force only. The object is on the surface of the water, or the object under the water, and the direction is from the upward. Guys, we have some notes. Look, the reason is that fluids exert an upward force on the object. Look, as I mentioned now, this fluid in here, we said it's water. So this waters exert force on the object. That now I said the Fb is the force of the water that exert a force on the object that are partially or completely submerged in it. This upward force is called buoyant force. In general, when the object is on the surface of the water or partially submerged, it means on the surface of the water or completely submerged, Fb can affect this object and the direction from the up. Because this is buoyant force, the object can stay on the surface. Look, we mentioned now, same, it's written, the buoyant force acts in the direction opposite of the force gravity. Guys, this is important. Look, for example, if this is an object, and we say that the Fb all time from the upward, but Fg is from the downward. So look that, it's written, the buoyant force acts direction opposite the force gravity. Of course, buoyant force from the up, but Fg from the down, opposite direction. We have another some notes. the direction of the buoyant force is always upward. We said, and even we said now it's opposite of the force gravity. Okay. Because of the buoyant force, things feel lighter under the water than the air. Guys, another things you have important. Look, again, let me make a picture. We have this is the surface of the waters, and this is again an object. Guys, this object is on the surface. It means that the object it doesn't goes under the water. The object is on the surface of the water. That means the object is outside the waters, and this is the object. What if we have same picture, but now the object goes sink or under the water? Do we have a difference between their weights, their mass? Of course we have a difference. Guys, this object is under the water, but that one is outside the water. So the object is outside the water. It means the air. We have a difference between their weights, their mass. This object, because it goes under the water, their mass or their density or their weight, it's become lighter. The things, the object that goes under the waters becomes lighter. But the object that they are staying on the surface of the water feels heavy. It feels like heavy, not lighter. The reason is why the object is under the waters becomes lighter, because when the object goes under the waters, and as we mentioned that, a buoyant force that can affect this object, a buoyant force that can affect this object, we said because it's the force of the water can affect this object. Because buoyant force affect this object, they will push this object to comes on the surface of the water. That's why their mass and their weight of the objects will be lighter, because the object goes under the waters, and we have a force on the object, the force of the water, buoyant force, that they can push this object to go up, and the object will be lighter. That's why. But the other object is still on the surface of the water, without pushing anything, without force. That's why their object it's not lighter, it's heavy. So this is important. That's not look, because of the buoyant force, things feel lighter under the water than the air. Because why? Because we say that under the water, buoyant force can affect the object. It goes push the objects to go up. So buoyant force depends on the object volume and the fluid density, of course. So it depends the type of the fluid or the liquid, if it's water or if it's oil or if it's mercury, because their density is different. The density of the water is 1000. If their density of difference can affect the object even. So of course it's different. Even the object volume, the size of the volume, is it small, is it large, both can affect the buoyant force. So guys, let me make it explain in detail. Look, for example, again, this is the surface of the water. Wait a minute, let me erase that one. Okay, let me erase this. Guys, look. For example, we have, if we have that one, we have. Look, I'm gonna make a picture now to understand better. Look, we have this surface of the water, and we have an object that goes under the water. It sinks. Any object, for example, circle, is on the water, underwater. This object, same object you have, is on the surface of the water. You know what is the difference between them? Difference between them by the weights, by their mass or by their weights. This object is inside the water, under the water, but this is no, it's outside the water, and it's in air. This object is feel lighter because the object is under the waters. Why it's become lighter? Because as we mentioned that in the water we have a force on the object, the buoyant force. can affect this object. They push this object to go and to stay on the surface of the water, to come here. That's why the objects become lighter. But this object is outside the waters, their mass or their weight is still heavy. So any object is goes under the waters become lighter because the force of the water that can push the objects can affect the object. And buoyant force is depending, the force of the buoyant force or the buoyant force is depending on two things. Depending on the object volume and the fluid density. Of course, the type of the fluid and the type of the liquid, both is important. If density will be changed, you have example. If the density becomes greater as 1, you have more maybe buoyant force. Of the density it becomes small, of the size of the object, both can affect buoyant force. Guys, we have another topic, it's called Archimedes principle. That topic. Okay. Look back. This topic, let me explain by this picture. On the picture, look. We have three. Let me explain what is the meaning of Archimedes principle. We have 3 containers, A, B, C. We have this container, and in here we have a small container. Look. Okay, guys, we have an object. This any object. We would like to bring down to goes under the waters. But in part A, I'm talking about the normal situation. In part A, the object they are suspended without going under the waters, and the object is outside the waters, and even you have this container is filled by the water. Okay, and part B and part C. Part A, the object they are staying like that without moving or bring down under the water. But look part B. Look part B. We brought down these objects a bit partially under the water, a bit partial in the water. Then have you noticed that? Look, some of the water comes out. A bit of the water comes out. So that means we brought down a bit of the object under the water. At the end, some of the water comes out. Look. What if completely the object goes under the water? So more water comes out. Look, more water comes out. And this is actually true. If you apply a bit of the object under the water, at the end, a few of the water comes out. But if you apply completely the object is under the waters, more water comes out. Look, because the object totally goes under the water. What does that mean? Wait, guys, look. So our example, we have some calculation. We want to find the weight of this water that it comes out. It's called Fg, or displaced fluid. Displaced fluid. The waters that comes out after applying any object under the water. Some waters comes out, we want to apply the weight of this waters comes out. We have some notes, guys, look. Part A, a brick is being lowered into the container's water. A bricks, they are in normal situation without brings downs, without putting the object under the water, part A. But part B, the brick displaced water causing the waters to flow into a smaller container. Look, guys, this object is called brick. This bricks, a bit, it comes under the water, a bit, not all, a bit. At the end, we feel that a few of the waters comes out to this small container. Waters flow into a small container. Part C, the brick is completely submerged. It means that the brick completely goes under the water. So of course, more water comes out. look at part D. Part D, it means this small container. Part D, the volume of the displaced water is equal to the volume of the brick. Guys, you know what that means? Does that mean, wait, how much is the size of this brick? The size of this brick, when you bring down the totally these objects and the waters, more waters comes out. This volume of the displaced fluid, we say this mean displaced fluid, the volume of this displaced fluid is equal to the volume of this brick that you brought down under the water. It means both of the volumes are equal. This actually is true. So it's depending the volume of the brick that you put under the water. If you bring down a bit of the bricks, a few waters comes out, like the bee's picture. Look, partially comes under the water, a few waters comes out, but that one is different. Look, totally the objects comes under the waters and more waters comes out. So that's why the volume of this brick is equal to the volume of the water. It's depending the volume of the brick. Okay, guys, what even I explained in here, it's written. But we have Archimedes principle is important to memorize. Archimedes principle, these principles can be started as follows. Any object completely or partially submerged, we say the brick completely or partially a bit comes under the water. In a fluid experience, an upward buoyant force is equal to the magnitude of the weight of the fluid displaced by the water. Guys, in this topic, when this process happens, when the bricks comes under the waters, the fluid experience upward buoyant force is equal to the magnitude of the fluid displacement. The FB directly is gonna be equal to FG. When the Archimedes principle happens, this process all times, and immediately buoyant force, it will be equal to the magnitude of the weight fluid displaced. It means Fg. Fg, that means this one, Fg. The weight of the waters that it comes out, this is called Fg, displaced fluid. Okay. Okay, guys. So we said that Fb all time is equal to Fg, and we know that Fg, according to the Newton's law, is equal to mg, mass of the object, and g, acceleration. Look, magnitude of the buoyant force Fb equal to magnitude of the buoyant force, it means Fb equal to weight of the fluid displaced, it means Fg. As is equal to what? Mass of the displaced fluid. Mass of the displaced fluid times gravity acceleration times g. Okay, so guys, this Fg is the weight of the water that is comes out on the small container after we apply the object. Look, this is the weight. This one, Fg, in the rules, Fg is the weight of this water that is comes out or comes inside this container, small container. Okay, guys, we have another rule. It's called F net, or total force. Net force or total force. Look, Baba, look, guys, let me explain in a detail. F net equal to Fb plus Fg. F net, it means the total force that can affect the object, and now even we study, and I told you the total force that can affect the object on the surface of the waters is two force: Fb, buoyant force, and Fg, gravity force. Okay, and look at this picture. For example, the surface of the water again, and that's all its water. the object is on the surface of the water. Two force can affect this object. FB from the up and FG from the down. Why in here the FG is becoming negative? Why? Baba, look. Again, bring it down FB. The FG is become negative FG. Why? Because the direction of the FG from the downward. That's why from the downward direction. That's why this positive is become a negative FG. Look. The positive is become a negative FG. Because the direction of the FG all time from downward. That's why the sign is become a negative. Guys, actually for using calculation, this rule so important, that one. This proving, guy, is not important, that one. Leave it. Just this rule, because we have example is important to know that. Now we mentioned that. We have this rule, Bab. Fg displaced fluid. It means that one. Fg. Look. Fg. Again, the weight of this water that comes out. We have to find Fg in the question. We have to find the Fg of this. Okay, look at the rule. Fg displaced fluid equal to what? Fg object in air minus Fg object in fluid. Look at this picture. So how we can find Fg displaced fluid? We said equal. Let me write in here. Fg displaced fluid equal to that's what it was. Fg displaced fluid equal to Fg object in air minus Fg object in fluid. So guys, look. This is the Fg of the object in air, and this is the Fg object in fluid. So we have to minus both. Then at the end we can get the Fg object, the Fg of this water that comes out by this rule. So you have to minus the weight of the object this in air, and the Fg of this object goes underwater. We minus both, we can get the Fg of the displaced fluid. Okay, and guys, look. And even in here, we mentioned that all time Fg is equal to Fb. So when you get the value of Fg, it means same value is equal to Fb because they are equal. So you have this rule. Important to memorize it. Guys, today it's enough. For the next lesson, inshallah, we will study when the object goes under the water or when the object can't stay on the water. We have some situation, and then we will solve example, inshallah. Thank you for all to watch my video. I have to get benefit from all my videos. Thank you again. Have a nice day.